The learning target today is for you to determine if polygons are similar, identify corresponding parts of similar polygons, and find missing measurements in similar polygons. It is your responsibility to turn the learning target into today's essential question. Some vocabulary: similar, same shape, proportional size, and our symbol for similar is just the tilde. Remember, you've seen the tilde before, so the meaning of the tilde depends on the context of the math problem. Back in the logic unit, it meant not or complement. Two polygons such that their corresponding angles are congruent and the lengths of the corresponding sides are proportional are similar polygons. And our last vocabulary word, the ratio of the lengths of two corresponding sides of two similar polygons, is called the scale factor. All right, let's take a look. We have what appears to be a quadrilateral. This first shape is probably a trapezoid, but we haven't been given quite enough information to determine that. In order to have similar figures, all angles have to have congruent corresponding angles. So in this case, angle H is congruent to angle M. Angle G is congruent to angle L. Angle F is congruent to angle K. And angle J is congruent to angle N. So I've met the first criteria. All corresponding angles are congruent. The second criteria is that corresponding sides are proportional. So that means that GH over LM will have to equal FG over KL, which has to equal FJ over KN, which has to equal HJ over MN. So let's take a look at those numbers. That would mean that 6 over 8 equals 9 over 12 equals 15 over 20 equals 12 over 16. So 3/4, 3/4, 3/4, 3/4. So I have a scale factor of 3/4. I have all sides proportional, all corresponding angles congruent, therefore these are similar. EFG. FG, HJ, go clockwise or counterclockwise, is similar to KLMN. Make sure you match the corresponding angles. Alrighty, now I've got triangles, and I'm given that angle B is congruent to angle E, but I'm not told any of the other angles, and all angles have to be congruent. Corresponding angles have to be congruent, or I can't use definition of similarity. So at this point, not similar. Might be that later, when we learn some similarity theorems, we can prove those triangles similar. But at this point, the fact that we don't have all of our corresponding angles marked as congruent means we're stuck. Alrighty, we have a 4 by 6 inch photo that we want to use for election posters, and we want our enlargement to be 26 inches wide. How long will the original be? Alrighty, so 6 over x will equal 4 over 26. 4x equals sorry about that, had to find my graphic calculator. 6 times 26, 156. So x is 39 inches. Whoops. Alrighty. You thought you might get away without any theorems. I fooled you by putting it on the second page. The similar polygons perimeter theorem says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So, if KLMN is similar to PQRS, so K to P, L to Q, M to R, and N to S, then the perimeter of KLMN over the perimeter of PQRS has to equal the length of KL over the length of PQ, or the length of MN over the length of QR, or the length of MN over the length of RS, or the length of NK over the length of SP, right? Because these all have to be the same ratio. Pentagon CDFGH is similar to pentagon JKLMN. Find the value of x. So C to J, D to K, F to L, G to F. Just like with congruent figures, you have to match the corresponding angles. So since G is in the 4th position, M is in the 4th position, that means those angles are congruent. Alrighty, so these are oriented differently. There's a reflection going on. It looks like x over 2 will equal 9 over 6. Simply solve the proportion. Verify similar triangles, then write a similarity statement and find the ratio of their perimeters. Alrighty, so first off I have to have 3 pairs of congruent angles. I do have angle P congruent to angle B, and angle Q congruent to angle T. Can I say angle R is congruent to angle S? Yes. Third angles theorem. So this does work for angles. Now I have to check my proportional sides. Proportional sides would be PQ over VT equals QR over TS equals PR over VS. So let's see. 9 over 6 equals 12 over 8 equals 15 over 10. 3 halves, 3 halves, 3 halves. So my scale factor is 3 halves. The perimeter of P triangle PQR over the perimeter of triangle DTS is 3 to 2, and my similarity statement, triangle PQR, is similar to triangle DTS. Make sure that you are matching corresponding angles. Kilogram JKLM is similar to PQRS. Nice of them to keep it oriented the same way for this one. Find the value of x. So 20 over 15 will equal 8 over x. Cross multiply. And x equals 6. And you're ready for a couple of questions and a summary.